Couple of days, you might have seen headlines asking if Mount St. Helens is about to blow. It's all after the area saw hundreds of recent earthquakes. So is there cause for concern? Fox 13's Shira Matsuzawa talked with the USGS to find out.
Recent activity at Mount St. Helens has reignited not just scientific curiosity, but also growing public concern. The central question haunting experts and lay people alike is chilling. Could this once catastrophic volcano initiate a chain reaction that might awaken the dormant, yet potentially world-altering, Yellowstone supervolcano? These two geologic giants stand among the most formidable forces of nature, with histories of destruction that defy imagination. The prospect of their simultaneous activity is a nightmare scenario. But how likely is it? To explore this possibility, we must delve deep into the hidden mechanisms that drive volcanic activity and unravel the connections, if any, that link these titans of the Earth's crust. A closer look at Mount St. Helens, past and present. Mount St. Helens, located in the Pacific Northwest's Cascade Range, is a stunning example of the beauty and danger posed by stratovolcanoes. Its distinctive conical shape masks a violent history of eruptions, none more infamous than the cataclysmic event of May 18, 1980. That eruption transformed not only the surrounding landscape but also our understanding of volcanic behavior. Months before the disaster, Mount St. Helens exhibited a series of warning signs. Earthquakes rattled the region, steam vents opened, and the north side of the mountain began to bulge ominously. Despite these indicators, no one could have predicted the scale of the eruption. At 8:32 a.m., a magnitude 5.1 earthquake struck beneath the mountain, triggering the largest landslide ever recorded. The entire north face collapsed, releasing pent-up pressure in the magma chamber and unleashing a lateral blast that devastated everything within a 230-square-mile radius. Superheated gases, ash, and rock surged outward at supersonic speeds, flattening forests, melting glaciers, and creating a plume that reached 15 miles into the atmosphere. The aftermath was apocalyptic. Ash blanketed 11 states and reached parts of Canada, while lahars, volcanic mudflows, carried debris over 50 miles downriver, destroying infrastructure in their path. The eruption reshaped the mountain, reducing its height by over 1,300 feet and leaving behind a massive crater that serves as a stark reminder of nature's power. Lessons learned. The science of prediction. The 1980 eruption of Mount St. Helens marked a turning point in volcanology. Scientists gained unprecedented insights into how magma movements deform the Earth's crust, enabling the development of modern monitoring techniques. Ground deformation, seismic activity, and gas emissions are now closely tracked to predict future eruptions. Advances in satellite technology and remote sensing have further enhanced our ability to monitor volcanic activity in real time. Between 2004 and 2008, Mount St. Helens experienced a series of smaller eruptions, forming new lava domes within the crater. These events, while less dramatic, confirmed that the volcano remains active and capable of significant eruptions. The region's population and infrastructure have grown since 1980, making preparedness more critical than ever. The dangers beneath, pyroclastic flows and lahars. Mount St. Helens' most fearsome weapon is its ability to produce pyroclastic flows, rapidly moving currents of superheated gas, ash, and rock that can obliterate everything in their path. These flows can travel at speeds exceeding 60 miles per hour and reach temperatures of 1,000 degrees Celsius, making them deadly and inescapable. During the 1980 eruption, pyroclastic flows reshaped the landscape, leaving a barren wasteland that remains visible today. Lahars are another significant hazard. Triggered by the rapid melting of snow and ice during an eruption, these mudflows can carry massive amounts of debris over long distances. In 1980, lahars reached the Columbia River, causing widespread damage. Future eruptions could generate even larger lahars, posing a severe threat to downstream communities. The Yellowstone question: a supervolcano awakens? While Mount St. Helens is dangerous on its own, the potential connection to Yellowstone raises the stakes. The Yellowstone supervolcano, located in Wyoming, sits atop one of the largest magma reservoirs on Earth. Its last major eruption, approximately 640,000 years ago, ejected over 1,000 cubic kilometers of material, dwarfing even the most powerful eruptions in recorded history. The global consequences of another Yellowstone eruption would be catastrophic, potentially triggering a volcanic winter and widespread crop failures. But could an eruption at Mount St. Helens trigger Yellowstone? The two systems are separated by over 500 miles and are driven by distinct tectonic and magmatic processes. While some scientists speculate that large-scale seismic events or shifts in magma pressure could have regional effects, there is currently no evidence to suggest that an eruption at Mount St. Helens could directly influence Yellowstone. However, the possibility of indirect interactions through complex geologic mechanisms cannot be entirely ruled out. Preparing for the inevitable. Whether or not Mount St. Helens and Yellowstone are linked, one thing is certain. Both volcanoes will erupt again. The key lies in preparation. Modern monitoring systems, emergency response plans, and public education are critical in mitigating the risks posed by these geologic giants. By understanding their behavior and staying vigilant, we can reduce the impact of future eruptions on human life and infrastructure. The story of Mount St. Helens is a testament to the power and unpredictability of nature. Its lessons remind us of the importance of scientific inquiry and the need for continuous vigilance. As we watch and study this active volcano, we are not just preparing for its next eruption, we are gaining insights that could help protect us from even greater threats lurking beneath the Earth's surface. The idea that volcanic activity at one site might influence eruptions or seismic events at nearby volcanoes is a captivating concept that has intrigued both scientists and the public for decades. This fascination is especially relevant in regions like the Cascade Range in the Pacific Northwest, home to iconic volcanoes such as Mount St. Helens, Mount Adams, Mount Hood, and Mount Rainier. These majestic peaks, situated within a geologically active area, raise a compelling question. Could an eruption at Mount St. Helens trigger a chain reaction, influencing other volcanoes in the Cascade Range? The phenomenon of volcanic triggering, where one volcano's activity initiates changes in another, is rare but not entirely outside the realm of possibility. Volcanoes in close proximity may share connections via common magma chambers, tectonic stress fields, or seismic waves. A large volcanic eruption has the potential to redistribute stress in the Earth's crust, potentially influencing nearby volcanic systems. In regions like the Cascade Range, where multiple volcanoes are part of the same tectonic system, such interactions are theoretically plausible, though not commonly observed. Volcanic triggering, evidence and mechanisms. The science of volcanic triggering is complex and multifaceted. There are documented cases of interactions between nearby volcanic systems. For instance, the 2018 eruption of Kilauea in Hawaii demonstrated this phenomenon when it caused seismic activity at Mauna Loa, another massive volcano on the Big Island. However, Kilauea and Mauna Loa belong to the same volcanic complex with interconnected magma systems and tectonic stress zones, making their interaction more plausible. In contrast, most Cascade Range volcanoes, despite their relative geographic proximity, lack such direct connections. Mount St. Helens, for example, is not known to share a magma chamber with its neighbors, such as Mount Adams or Mount Hood. The 1980 eruption of Mount St. Helens, while powerful enough to alter the local geological landscape and increase seismic activity in the region, did not trigger significant eruptions at other Cascade volcanoes. Conclusion: independent giants. The question of whether Mount St. Helens could trigger Yellowstone's supervolcano is a fascinating one, but scientific evidence firmly indicates that the answer is no. The two volcanic systems, though both formidable in their own right, operate independently. Mount St. Helens is driven by subduction zone processes, while Yellowstone is fueled by a deep mantle plume. Their geological mechanisms are distinct, and no direct connection exists between them. While the risks posed by these volcanic systems are real, they are separate and should be treated as such. Mount St. Helens will likely erupt again in the near future, posing localized threats to the surrounding region. Yellowstone, though capable of producing a supereruption with global consequences, is a far less immediate concern. For now, the focus remains on continued monitoring and preparation, ensuring that we are ready to respond to these natural forces whenever they awaken.